Okay, so I'm going back and I'm talking about some of my old devices here. So this was one of the earlier uh, solar powered flashlights essentially that I made. So this one has a 2.5, 2.5, 2.5 volt solar panels in series, and then so that would be no wait no all of these are I think maybe these are in series. I don't remember. Um, and then there's another set on the back. I think these are in parallel. I think there's two sets in parallel. Okay, and then I put those together in parallel. I think these are in series, and these are in series, and then those are together in parallel. Yeah, and so this should be like 7.5 volts or something. So anyway, it's got a USB connector on the side here that you can then plug in a USB light or some very small small amp USB device, because this only puts out like 200 milliamps at 5 volts. But the benefit of this, turn it on for you for a second. Is this charged? I don't think I charged it. Off, on. I don't think I charged it. I think it's been sitting in the dark. I'm still gonna go over it. Anyway, this does work. It is bright. Yeah. So let me pop this thing open. Give me a second. Got these little. I made it out of little screw boxes, I think, from Home Depot, and they have these little tabs on the side. There we go. They have these little tabs that you can pull off. The benefit of that is I could reopen them back up, and I had coated these boxes with some Velcro. So I open this up, and now I have a lid, and then I have another lid here. So this was screw box number 1, and then their box number 2. Inside of that, let's see what I got, because I don't remember. So this is, I think these were like 30 farad capacitors or something. Okay, these are 15 farads. 5.5 volt, 15 farads. Oh, so you know what? Okay, I'm pretty sure that that I would not. So I'm positive that these are all wired together in parallel. So what that means is that actually these solar panels are only in parallel. Because I would have taken 2.5 volts, which has to be less than 5.5 volts here. 5.5 volts, 15 farads. Because otherwise it would hurt these. But the point is, this will sit in the light somewhere in a window. It'll charge up these supercapacitors. That's a lot of capacitors. Then those go into a voltage booster in the back that goes from 0.9 to 5 volts, only at 200 milliamps, that then comes out to USB. So this is kind of, it's a little bit the size of a phone. But the point of this is, if you're using capacitors rather than lithium-ion batteries, and this will really work in the case of an emergency, as long as in the middle of the night, as long as you actually leave it near a window, and it won't go bad like lithium-ion batteries do if you have those for some kind of emergency flashlight. Because a lot of times you'll buy these things that go into your wall socket, that says, oh, this is an emergency light that turns on when the power goes out. But if you leave them in there for 2 years, well, the batteries in them goes bad. And then you don't know. And then when you finally do get an emergency, then you're not prepared. So anyway, using capacitors instead is supposed to be better. That said, the way they make those capacitors that I showed you in there, those large 15 farad 5.5 volt ones, is they actually put 2 capacitors in series inside of those. And there's no balancing. So it means that those capacitors, rather than lasting 300 years like they normally would, they're only going to last for 10 years. So this is not actually the best emergency device. So I made another video right before this to explain that. So the capacitors in here will go bad, but should be longer than lithium-ion batteries. Yeah, it's a shame I didn't have this in the light because that normally works. All right, goodbye.